Hi everyone, let's do Leetcode 15, threesome. Before trying to attempt this problem, I highly suggest that you look into these two Leetcode problems, twosome and twosome 2. Doing these two problems before threesome is going to help you understand this problem better. Let's read the problem. So given an integer array, we want to return all the possible triplets that add up to 0. So we are looking for three numbers that added up together are going to give us as a result 0. We have an example here. We have two possible triplets that are going to add up to 0. We need to make sure that the solution set is unique. So we can't have repeating triplets. So these have to be unique. The first possible solution is to use brute force, so we can have three nested loops and we're gonna add each element together, and if they sum up to 0 we can have a result set that is going to contain all the triplets that are going to add to 0, and then we can simply return this. But we need to make sure that we don't have repeating triplets. As you can see here, we have some numbers that repeat themselves, so we would have to take care of that as well. There is a simpler way to do this. Let's look into that. So one way of solving this problem is by sorting the input array. On the right here, we've got the sorted input array. What we can do is, we first get the first element, -4. We need to make sure that we are not gonna reuse the same element. So what we will need to do is, when we reach this point here, we see that is again the same number as before, -4. We will need to check if the previous number, which was the left neighbor, is the same as the current number. We are just going to skip it, and we will have a to be -3 instead of -4. So this is something that we will keep into account when writing the code. Okay, we have set the first letter A. We now need to find B and C. For this, we can use the same way we use two pointers in twosome 2. That's why I highly suggest to watch those videos first. So we have 4 equal to A, and now we will need two pointers, a left pointer and a right pointer. We will get these two numbers, so in this case it's -4 and 3. We will sum. Is this equal to 0? No, it's not. The sum is actually smaller than 0, so it's -5, which is smaller than 0. In this case, we will need to move the left pointer up one position, so it's going to be here. So now B is going to be -3. R is going to stay the same. So is this equal to 0? No. Now we will have this case, we have the sum is equal to -4. Again, it's still too small. We are going to move left again. B will now be 0. Is the sum equal to 0? No, it's not. It's actually equal to -1, which is still smaller than 0, so we need to move R again. Let me clean up this mess. So now we need to move L again. L is going to be 1. Is the sum equal to 0? Yes, it is. We are going to add this triplet to our result, -4, 1, and 3. So this is one of the possible solutions. Again, we will do this for each value in the array. We will return this. What is the time complexity of this solution? So because we are sorting, that's going to be O n log n. We are going to have two for loops, one for the first number. We're going to have also a for loop for left and right pointer, so that's going to be O of n squared. And as we know, we take the biggest one, so the time complexity is going to be O of n squared. Memory complexity, if you assume that sorting is not going to take any extra space, memory complexity is going to be big O of 1. Let's try some code now. So the first thing we need is a result list, which is going to contain all the triplets that we're going to return. Next thing we want to do is to sort our input array. So we can use the built-in function .sort. We now want to iterate for the first of the triplets, so A, and we can do this using a for loop. We're going to use enumerate because we need both index and actual value. We need an if condition to make sure that letter A is not actually the same as the previous one, so we're just going to use a simple condition if I is greater than 0. If the current number is the same as the previous one, we want to skip. Okay, we now want to do the second part. We have set the first number. We need to do the same thing we did in toSum2 with the input array sorted, so we need a left pointer and we need a right pointer. We need a while loop, so the condition is going to be left smaller than r. We're going to calculate the sum and check whether it's equal to 0 or not. So we want to sum n plus the number at position L and the number at the pointer r. As we said, if sum is greater than 0, we want to decrease the sum, so we're going to move the right pointer by 1. Otherwise, if the sum is smaller than 0, we want to move the left pointer by 1 place towards right. And if none of these two conditions are true, it means that we have found a triplet that sums to 0. We want to append it to the result. So now we need to increase one of the pointers. I'll explain a bit why increasing one is enough. We want a while loop. We want to make sure that L is not going to be the same as one that we just put in the result triplet. So we will need this extra while loop. We want to make sure that the new L is not the same as the previous L. So let's take this example to explain why we just need to increase one pointer. So it's enough to increase one pointer because let's take this example. If L was here, we are going to move it here. And because of the this while condition, L is now going to be at 0. If R was here and we have just increased L, when we're going to reach these conditions here, these conditions are going to make sure that R gets moved. So if R was here, let's say the sum is greater than 0, so we want to move R. And because of this condition here, R is still going to be moved, so increasing one pointer is enough. So after we have done all of this, we can simply return the result triplet. So let's see if this works. Yes, it does. Please like and subscribe if you found this video useful. Thank you.